Now this question 124 is based on RMS speed. Here you see the RMS velocity has been given 200 meter per second at temperature 27 degrees Celsius and pressure 10 to the power 5 Newton per meter square. Now the temperature and pressure they have changed. So remember here the pressure change will not be affecting the RMS speed. It's only the temperature change. It is proportional to square root of absolute temperature. You see. So the whatever pressure change has been given, don't worry about it. Just think of the temperature change. So here 200 is proportional to square root of 300 Kelvin, because 27 degrees Celsius will be 300 Kelvin. And the value you are supposed to calculate, that is at 127, that is 400. Now if you calculate the value here, V, so that will be how much? If you consider this thing, that is under root 3 by, so 400 by root 3, that is the answer I will be marking. That is option number 3 will be the correct option for question 124. Now let us switch over to question 125. Now here this question 125, it is based on closed pipe, and here you know that in closed organ pipe the frequencies are in the ratio 1:3:5 and so on. It says that an air column closed at one end and open at the other resonates with a tuning fork when the smallest length of the column is 50 centimeter. So if you have the organ pipe, then you see this is the 50 centimeter mark that has been given to you. This is the fundamental vibration. Now it is asking you to calculate the next larger length of the column resonating with the same tuning fork. So next larger length, as you have seen in resonance tube experiment. So this is the next larger length. So 50 is this and 100 will be this. So in total, the total length of the pipe will be 150 centimeter for this particular question. So I will be marking answer 4 for this question 125. Now let us look at the next question, that is question 126. Now this is an information based question in which magnetic susceptibility is negative for. You have to mention whether it is diamagnetic or para or ferro. You know that it's only diamagnetic substances which have negative susceptibility, para and ferro have positive, isn't it? So the correct answer for this thing will be second option. First is saying paramagnetic and ferromagnetic, both of them have positive. Here diamagnetic substances have negative susceptibility. So these are not the correct options. Second option will be the correct one for this. Switch over to next question, question 127. Now in this question 127, you are supposed to take the ratio of de Broglie wavelength, lambda. You have to use different formulas for electron and photons. It says that an electron of mass m and a photon have same energy E, the ratio de Broglie wavelength associated with them. If you use the formula for electron, it is h upon under root 2 me. Understand? And for photon, it is energy is equal to hc by lambda. So lambda for photon will be hc by E. So you have to take the ratio of both of them. So if you take the ratio of both of them, you will be marking answer 2 for this question 127. Now switch over to question 128. Now in this question 128, it says that a body of mass 1 kg begins to move under the action of a time dependent force. Force is given as a function of time. And they are asking to calculate the power developed. Power is what? Power is force dot velocity vector, isn't it? Now you see, force is same, 2t I cap plus 3t square j cap. You have to calculate velocity, and velocity is nothing but integral of acceleration. Here acceleration and force magnitude wise they will be same because mass in 1 kg. So you are supposed to integrate this thing, 2t I cap plus 3t square j cap to be integrated with respect to time. Now what do you think? What will be the value of this? This is t square I cap plus tq j cap. This is the velocity. And you have to take the dot product with force. So power is equal to, now see, force is 2t here and this is t square. So dot product of that thing will be 2tq, isn't it? Plus This is 3t square and t cube. This is 3 into t raised to the power 5. This much watt. So for that matter, the correct answer will be the first option for this question 128. Now switch over to next question, that is question 129.